Hey everyone, and welcome back to the AI Research Roundup. I'm your host Alex, and today is May 3rd, 2025. We're kicking things off with this ICLR conference paper, published just over 3 months ago on January 22nd, titled Progressive Compression with Universally Quantized Diffusion Models. Okay, so this paper introduces a way to make progressive data compression using diffusion models actually efficient by replacing the usual Gaussian noise with uniform noise, allowing faster encoding. Alright, so this first figure gives us a nice visual comparison. It shows example image reconstructions from the new UQDM method alongside traditional codecs like JPEG and BPG, plus other neural codecs like CTC, all at roughly similar bit rates. You can see, especially at higher bit rates, how UQDM tends to preserve details, like the spider shape or the calligraphy sharpness, better than some others. It also shows different UQDM decoding methods, which is interesting. Okay, moving on to figure 2. This shows results on some toy swirl data. The left plot, well, it demonstrates that learning the reverse variance, shown in orange, is really key for UQDM's performance, achieving the best results around just t equals 5 steps. The middle and right plots then show progressive compression, comparing UQDM's PSNR and realism against bitrate for different t-values, showing it performs quite well even with few steps. Building on those toy examples, Figure 3 now shows the progressive compression performance on a more standard dataset, CIFAR10. We see 2 plots here. On the left is fidelity measured by PSNR versus bitrate, and on the right is realism measured by FID versus bitrate. Okay, so UQDM, specifically using t equals 4 steps, is compared against JPEG, JPEG 2000, BPG, and also that theoretical VDM. It looks like UQDM beats JPEG and JPEG 2000 pretty handily, and even surpasses BPG's PSNR at higher bit rates. So now we move to Figure 4, looking at the ImageNet 64 dataset. Similar plots here, PSNR and FID versus bitrate. Again, UQDM with t equals 4 steps is compared to others like BPG and CTC. What's notable is that while other methods like CTC seem to level off at higher bit rates, UQDM just keeps improving both fidelity and realism. It also consistently outperforms JPEG, JPEG 2000, and CTC across the board. Okay, so Figure 5 gives us some qualitative examples of these progressive reconstructions, again using UQDM with t equals 4. It shows 2 different decoding methods side by side, denoised prediction on the left and ancestral sampling on the right. Well, you can see how the quality improves with bitrate for both, but ancestral sampling seems less blurry, though maybe a bit grainier at the lowest bit rates. It's a nice visual of the trade-offs. Alright, and Figure 10 here provides some additional example reconstructions, this time focusing on roughly similar low bit rates. We see UQDM again, with ancestral, flow-based, and denoised outputs compared against JPEG, BPG, CDC, and CTC. Well, even at these lower rates, UQDM often holds up quite well visually, especially the flow-based and denoised versions, appearing competitive with, or better than, several alternatives shown here. Okay, so wrapping things up on UQDM, the key idea is replacing Gaussian noise with uniform noise, which makes progressive diffusion compression efficient using universal quantization. We saw strong results across the board, often beating traditional codecs and competing well with other neural methods, impressively even with just 4 or 5 steps. This really brings practical progressive neural compression closer. Thanks for watching the AI Research Roundup. I'm Alex.